up to point to my web server. Now I'm the proud owner of this nice 425 phone number, and I'm going to put a URL in here so that every time Twilio gets an incoming SMS, it'll make a request to that endpoint. So what happens when it makes a request to that endpoint? When it hits that endpoint with the body of the text message, right, it'll look for instructions on what to do next. And those instructions are written in what's called TWIML. And TWIML is pretty human readable. It's essentially XML. And you can tell it things to do, like send an SMS or dial a phone number. So I'm going to say, thanks for texting in. And that's a full application. So if you guys can pull out your phones and send a text message to that number, you should get that reply back momentarily. And let me know if you don't. But I'll do it too. So that's all kind of cool, right? Like you can send text messaging, you can send automated replies, you can send dynamic replies. But what I'd really like to do is call all of you. So let me know when you start getting replies back from Twilio. Okay, cool. So now what I'm going to do is pull all of those text messages that we just received and call all of you back. So in order to do that, I'm going to require my credentials, my API key, and a helper library. The helper library is basically just a wrapper around the API. There's helper libraries for PHP, Ruby, .NET, Java, Python, Node, like whatever you want to use. There's probably an Erlang one in there somewhere. And what we're going to do here is set up an object that is going to access the API. And we're going to get our phone number as well. So now that we have all of this set up, I can actually just go through and loop through every SMS message that I've ever received. And I'm going to filter out all of the SMS messages that are just to my phone number. And what we're going to do here is print out the body of your message. So SMS body, actually let's say SMS from, and then SMS body. And then we're going to call you back. So it's from my Twilio phone number to your phone number. And we're going to pass in another one of those TWIML URLs. So does this all make sense so far? Right? We're pulling all the SMS messages. We're filtering out only the ones to this phone number. Then we're printing them out and calling you back. So when we call you back, we're going to be looking for instructions at that conf.php URL on what to do next. So I can go in here and write another very simple, straightforward TWIML document that will say, hello there, and dial you into a conference room called tech@NYU, and that is it. So now when I run this script, all of our phones theoretically should ring. You never know when you're writing code on stage, but let's see what happens here. Awesome. Let me know if your phones are ringing. They should. Pick up, pick up.
Hello. Hello.
Hello. Hey. So that's how Twilio works. And what I did with this robot is I took that framework, right? It's a REST API, and I wrote essentially a controller for an Arduino-powered robot. And the way that controller works is you dial into a phone number that's sitting on top of Twilio, and you press digits within the call to drive the robot. So it's kind of crazy, but it's kind of neat that you can do it with any type of phone, right? Like landline, feature phone, cell phone, it really makes absolutely no difference. So, now to get to the meaty stuff. Okay. So, robot world domination, right? We all know it's coming sooner or later. We've all seen Google Now. They know everything about us. It's leading to Skynet. And I'm going to show you how you can take advantage of it for fun and profit. So, the Robopocalypse. This is an Arduino. An Arduino is an embedded microcontroller that is very cheap and very open. What is it? So, it's open source software. I'm sure all of you know what open source software is, but in this case it means that all of the code that has anything to do with this device is open. So that's the IDE, that's the libraries that power it, that's all of the libraries in the community. It's basically everything that could possibly be open about this is open, including the hardware. So anyone out there can go download schematics for this little circuit board and print them themselves, right? This is a name brand Arduino. It's branded, they print them, they sell them, but anyone in the world can go take this and print their own and build their own for next to nothing. So it's extremely cheap and extremely accessible. It's embedded computing. That means that you can essentially write applications that interface with electronic sensors, right? It's not a full-fledged operating system like the Raspberry Pi. It's just a very basic system to interface with different sensors. So inputs, outputs, I'll show you a little more later. So the hardware aspect, it has flash storage. So there's a little chip on here that stores all of your code. You download the code with the IDE, and it will just run every time you boot up the Arduino. It has RAM for in-memory storage, just like your computer. It has digital I/O. So it has 13 pins here that you can plug any sort of digital device into, and it will detect the voltage, and you can write code to interface with that. It also has analog I/O. So you can attach any analog device. So an example of an analog device, right, might be a distance sensor, where it's not simply an on-off or high-low value. It's a sort of value that might change depending on how far something away is, right? And that value is actually a voltage that's being transmitted to the Arduino. So it can detect inputs, and it can also use all of these ports here as outputs. So you plug wires in, you can use them as inputs or outputs. It also has a number of plug-and-play extensions. So a plug-and-play extension in the Arduino world is called a shield, and it literally just plugs right into the Arduino. There are shields for any number of things, motors, LCD screens, Wi-Fi chips, 3G, right? Anything you could possibly imagine there's probably a shield for. And it's pretty nice because if you're not an electrical engineer, they often solve a lot of the hard work for you in interfacing with this device. So you don't have to worry about wiring or resistors or any of that crap. It's just a plug-and-play thing. So the software, there's an IDE. You upload all of your code via USB to the Arduino. There's tons and tons of open source libraries for anything you could possibly want to do. And there's an extremely active community that will help you not burn down your house with robots. So let's dive in here and do a little code. So what I'm going to do here is sort of show you some of the hello world examples of working with Arduino. The first thing to mention is that every Arduino application has two functions. There's a setup function and a loop function. The code that this is written in is will look pretty similar to C. It's not really C. It's sort of called processing, but you don't really have to worry about that. It's very intuitive. So it has a setup function and a loop function. The setup function runs every time you turn your Arduino on, and the loop function runs constantly after that. So as soon as the setup function is done executing, the loop function will loop, right? It just runs over and over and over and over until the power dies. So what we're going to do here is we are going to make a little light blink on and off. It's not very exciting, but it's basically the canonical hello world of Arduino. So we have an LED, right? It's a little red light. It has two pins. It has a ground pin and a voltage pin. Luckily on the Arduino we have ground and voltage, so I can just plug it right in. And then when I plug this into my computer, I'll be able to download code to turn the light on and off. So, what does that code look like? Whoops. So the first thing we have to do is tell the Arduino which pin we're controlling. So we have an LED pin, it's 13. They're numbered on the little device here, you can come look later. And we're going to tell it that the pin output, right, is going to be, sorry, the pin direction is going to be output. We're only outputting data to this pin, right? And then we're going to loop through, and every sort of 1 second, we're going to turn it on or off. So digital right, LED pin, high, that'll turn it on. Then we're going to delay for 1 second, and then we're going to turn it off. And now when I download this, it should just run. So let's do that. There we go. I had it in backwards. So yeah, like that's the hello world of Arduino, right? We have a script here that's literally just looping through and turning a light on and off. So that's kind of neat, but it's really not that exciting. Dealing with sensors, in my mind, is much more interesting. So what I'm going to do now is I'm going to connect a button to this Arduino that allows you to press to turn on and off, rather than simply doing it via timer. So, the way you interface with a digital button, right, is the same as you interface with that LED. So it has 2 pins. There's a voltage pin and a ground pin, high and low voltage basically. And you simply have to plug it into the Arduino in a digital port. So I'm just going to plug this in here. I'm going to put in pin 5 and then ground. And we're going to change our program so that rather than just having our LED pin, we also have a button pin, which is in the input mode. So rather than writing high and low willy-nilly, we're going to do a digital read and get the value of the button pin, right? So every time this loop runs, it's going to be looking at this button to see what voltage it's providing. So let's download this. Okay, so now when I click this, whoops, assuming it's all plugged in properly. Oh, there we go. Oh, my pins are a little funky here. Debugging hardware is much more interesting than debugging software. Oh, there we go. Okay, so I'm clicking it on and off. Okay? So that's taking an input from another digital device and outputting it to the LED, right? So that's pretty simple to do, but you can get sort of more interesting and do stuff with analog inputs and outputs as well. So, as I mentioned, analog outputs can be anything from like a distance sensor to a potentiometer, right, to maybe a heat sensor, something with maybe checking the amount of moisture in the air. There's a million different things you can do. I happen to have a little potentiometer, right, which is basically a volume knob. And I can plug it in, and then basically, depending on where this is turned, it's going to output a different voltage to the Arduino, which is detected, and we can output it to the user. So, what we're going to do here is we're going to have our pot pin, output in number 7, and what we're going to do is we don't even need a setup because it's analog. And we're just going to use the serial port to output data. So when the Arduino is plugged in via USB, it is actually connected via USB serial. So you can output data over a serial port here into a monitor in the Arduino IDE. It's really useful for debugging, though some chips override that. So I'll talk about that a little later. But basically what I can do here is plug all of these into the Arduino. So I have 5 volts. I have ground. And I have my fancy little analog value. And we're going to write the output of that analog value. So serial.println, analog read, hotpin, right? So it's going to get a constant stream of information. So now when I download this, okay. Now if I open up my serial monitor, you'll see that it's turned all the way one direction, which is 1023. And as I turn it, that value is going to change, right? So this is an analog input, right? It can vary more than just high or low, which is what the button and the LED do. Okay? So those are sort of the Arduino basics, right? That's the hello world of Arduino. You have analog, you have digital, and you have inputs and outputs. So that kind of, those basic principles are what open up all the other crazy possibilities of things you can do. And one of those things is building ridiculous robots. So, let's go back and look at this robot. So, what is the TwilioBot? So as I mentioned, it's a robot that you can dial into and drive around with dial tones. It actually has pretty simple parts. You have an Arduino, you have a Wi-Fi shield, which allows it to connect to the internet. You have motors, and you have a sonar sensor. The sonar sensor is not really necessary. It was just kind of a fun thing I added. And so we're going to walk through and talk about what all this does. So as I mentioned, right, Twilio can communicate with web servers, and so can this Arduino. So the Arduino is able to open up a raw TCP connection to a server. And what we did here is build a Node.js server that communicates with both Twilio and the Arduino. So on one end, you have all of the data coming in from the phone lines, and on the other end, you have a basic TCP connection between this and a server. So this is the wireless SD shield. It allows you to connect to the internet. It's actually not only for that. It's simply a shield with the pins that fit a very common type of wireless chip. I happen to have a Wi-Fi one, but there's also XB, if you've ever heard of that, and a couple others as well, and it's just a plug-and-play thing. Makes it a lot easier to interface with, because there's like 30 pins that you would have to wire on your own. We also have a basic LED to show you when the robot is connected to the network. And then we have power. So all of the motors and all of the sensors need 5 volts of power. Luckily, the Arduino outputs 5 volts of power. So what you can do is you actually plug the Arduino into a power source, and it can independently power all of its sensors and motors, right? The only time you would have to worry about sort of external power sources is if you're really doing like high, capacity stuff, right? If you have big motors or really like demanding chips. We also have digital outputs and inputs. So for both of these motors, we're using servos. And I'll talk a little bit about servos later, but we're controlling them via digital output. We also have a sonar chip that reads in pulses via digital input. So this chip is sending out sonar waves and reading back the values to you at specified intervals. So you can determine how many inches away an object is in front of the robot. Then we have the Wi-Fi chip. As I mentioned, it's a form factor that's pretty common in Arduino, but this one happens to be for Wi-Fi. It's kind of an interesting chip because you communicate it via serial. So if any of you have ever used like a terminal somewhere, that's basically how the Arduino talks to this Wi-Fi chip. It's sending it commands like connect or send this data, right, or open this IP address. It's all text-based. So let's dive into the code a little bit. Can you guys read that at all? Is it too big, too small? Huh? Too small? Well, we have some issues with this, but I'll explain it as we go. So, the basic premise of this application, right, is that we are opening a TCP connection from our Arduino to a node server. And the Arduino communicates with that node server to determine what to do next. So this block of code here, right, which some of you may be able to read, literally all it's doing is connecting to a network, right? It connects to a Wi-Fi hotspot with the username and password, just like you would on your computer, and then it opens up a server IP and port, right? So it's opening a TCP connection to that server and port. Then, as we connect, we want to loop through and be able to detect the data. So the only way to interact with an Arduino in real time is via this loop. There are some concepts of interrupts and sort of asynchronous programming, but it's really just the loop. So as we're looping through this connection, right, and this is constantly happening on the Arduino, we want to be able to detect if we're connected to the server, right, and turn on and off that LED, and if there's data available. So because this is all sort of, it's not really real time, right? There's this delay in this loop. We're actually constantly checking to see if there's data waiting on our Wi-Fi chip that we could process. We also have some servos we have to set up. Luckily, there's a servo library that we can use to plug into. And we have movement functions. So how many of you have used a servo motor before? No one. Okay. Well, maybe a couple of you. A servo motor is not like a typical DC motor. So a typical DC motor, you apply a voltage to, and it will just spin, right? It just goes. A servo motor only moves 180 degrees. So it can go from here to here, and that's it, right? That's all it does. It's great for moving arms, it's great for like controlled movement, but it's kind of useless for robots. So someone somewhere figured out how to modify a servo so that it can be used as an actual driver. So the two servos I'm using here are modified for what's called continuous rotation, which means that there's a gear taken out somewhere that allows it to spin essentially forever. So when I tell it to go to 0, right, which this is position 0, it'll just keep moving in that direction forever. If I tell it to go to 180, it'll keep moving in that direction forever. It doesn't just stop at either side. So we have some basic functions here to tell it to move forward, move back, move left, and those are just things that I figured out. Then we have our dial tones. So the Node.js server, which I'll show you in a little bit, is actually taking post requests from Twilio. So every time you push a button on your phone, Twilio sends a post request to your server, and the server, in turn, will send that data along to the Arduino as a text string, right? So it's literally sending the number 2, or the number 4, or the number 6, whatever, right? It's sending that along from Twilio to the robot. And we're just processing that and determining what directions to go, and then we send a confirmation back to the server. So we also have this little sonar chip, which I mentioned. The sonar chip is sort of an example of two-way communication, right? When you're receiving the commands from the phone to the robot, it's one way. You know, it just goes in from Twilio to the server to the robot. The sonar is two-way, so we send a request from Twilio, right? You hit the number 5 on your phone, and it sends that along to the robot, and the robot actually responds by getting the value that this sensor is detecting, right? So it knows how far in front of it some object is, and it'll send that back to the server to be read out as speech, right? It's text-to-speech. Then we have, so now that we have the robot like done, basically, right? It's not really doing anything super complicated. We have the Node.js server, which is the other side of this project. So how many of you have used Node before? Okay, a couple of you. So for those of you who haven't, Node.js is basically an asynchronous back-end framework for writing JavaScript. So many of you have probably written JavaScript on the front end, Node allows you to write it on the back end or on scripts or in your terminal. It's very sort of powerful, and it allows you to do really intuitive asynchronous programming. So traditionally, when you write an application, right, the application just runs straight through, right? It just runs. The whole function will run at one time. In Node, it actually responds to sort of triggers and will run different pieces of code at different points of the application lifecycle, right? So if someone clicks a button, that could run a specified piece of code, right? It doesn't need to constantly execute. And the same thing works for how it interacts with Twilio. So when we get an incoming call, Node knows to execute a specific piece of code that we have that tells it to read out instructions to the user. It then requests digits, right? So it's going into a piece of TWIML, just like that XML we saw before, that requests digits from the user. When we get those digits, we are going to look and see first if we're actually connected to the robot, and second, if they're in a list of accepted commands, right? So we accept 2, 4, 6, 8, 0, and 5. If it's within that list, we write the data to the Arduino so that it can run and figure out what to do next. And then it continues to gather digits. So every digit is a new post request, and we're continuously gathering digits until the call is over. We also have a TCP server. So the way Node interacts with Twilio is via using this library called Express. It's a HTTP web server library, right? It allows Node to process, post requests and GET requests and all the fundamental web requests. We can also open raw TCP servers. So how many of you are familiar with like the concept of TCP and HTTP and all of that? Some of you? Okay. So TCP is essentially the fundamental protocol for the web, right? There's TCP and there's UDP. Browsers work with TCP. So when you go to load a website, what it's actually doing is sending along some commands over this protocol that the server responds to and sends data back, in response to your request. It's essentially all raw text, right? It's all text. And HTTP is a layer on top of that. So when you see GET and when you see POST and when you see update and delete and all of those commands, they're being sent in a textual format over TCP sockets, right? So TCP is this fundamental layer. HTTP sits on top of that. So when you're writing a web application, you generally only interact with HTTP, and you generally only interact with it in sort of an abstract way, right? If you're writing something in Python or Ruby, you are responding to a certain type of request, but you never have to analyze that text yourself. In Node, it's actually possible to go a little bit deeper and interact purely with TCP, right? So there's no text layer on top of that. It's just raw data coming over the pipes. And that's how it interacts with this robot. We could theoretically use basic HTTP, right? Set it up like a web server, but it would actually have a lot more latency. So it would be a lot slower if we were using HTTP and using a web server rather than just using raw data. So we set up this server for the robot to connect to, and that is how this whole thing works. So I was having some issues earlier with connecting to the network. I'll see if I can get it working now, but until then, does anyone have any questions about all of this? No questions. Okay.
Well, not about this particularly, but I heard you just did not like a partnership, but implemented some features with Google. How does that relate to the rest of the company's plans?
Are you wondering about the App Engine partnership specifically, or how that reflects on the bigger picture?
I guess just the bigger picture. I mean, if no one has any questions about this particular implementation.
I mean, we're always trying to look for interesting partners to work with. Google is kind of an obvious one because they have probably the best Python hosting platform out there, right? So with App Engine, it was really just a question of getting it done and modifying our libraries so they work properly. It's not necessarily a crazy part of our strategy, but we're always looking for people to partner with. So,
okay.
Just to recap the node server. So you're running your Express server, which
Yep.
is Twilio is sending the post request to that with every dial tone?
Every digit.
Every digit.
Yeah.
Okay.
So in Twilio, a digit is essentially you have a gather block where you're telling it gather this many digits, and then you give it an action URL. So when it's done gathering those digits, it makes a request to your server.
I see. And then you have the TCP connection to the Arduino open the whole time, and when you receive the post request, you'll send it to the Arduino. Or
Yep, exactly. So node server is really just sitting in the middle, right?
Right.
Just because, as I said, like doing the web server on here would be too much.
Right.
Let's see. Does anyone have tethering on their phone? Because I had it running on my MiFi here, but it doesn't seem to be working right now.
Yeah, I think I can just tether the like NYU network.
Oh, can you? That'd be crazy. If not, I can
You
show
just
you a
need, like, a
video of it, but that's
public
not nearly
Wi-Fi?
as exciting. What?
You just need like a public Wi-Fi.
Yeah, this is public Wi-Fi. Any questions about Arduino, about Twilio, about anything?
Is there new tags called like SIP?
Yeah, it's a SIP.
It's not instead of like conferencing is 1-to-1.
So, SIP is, so I mentioned there's TCP and HTTP. SIP is another protocol.
Oh, it's not a tag. Like one
SIP
of
is a
the,
protocol. So, SIP is generally used for media, right? So video, audio. It's actually used by a lot of telcos, by a lot of phone companies to communicate with each other. It's also used for a lot of traditional like call center software. So we just made it possible to call from Twilio to like a server that's running SIP. So.
Can you just show the code, the Arduino code, which connects to the node server?
Yeah, absolutely. Let's see. So this is it. Basically, yeah, here it is. So we're communicating with the little Wi-Fi chip via serial, and then we just send it along SSID and password and.
And so then how does it
Server
read
address.
anything that gets sent over from the node server? Do you just have to like in your loop constantly like wait for anything coming?
Yep. So in the loop, we are checking for available data here,
Okay.
and then we just read it out into a character,
Okay.
and then we can
So
check
it's
the
just
value
like
of
a
that.
big if statement if there's data available then.
Yeah, and it's constantly checking that.
Right. Okay. As far as like node goes, do you have to have like what does it look like to actually connect to the Arduino?
So the Arduino is connecting to the node server.
Oh, I see.
Right, so this doesn't have a public IP address.
Okay.
The node server does, and this is just reaching out to it, and it just leaves the socket open.
It's just leaving the socket open and then when it gets connection.
Yeah.
Okay.
So
Hey, so this is up. It's probably
Awesome.
gonna be slow because it's like
it doesn't matter. What's it called?
stoked.
Stoke. What's the password?
1, 2, 3, 4, 5, 6, 7, 8.
Okay.
Had to be 8 characters.
Is that it?
That's right.
Okay. So I'm gonna plug all this back in and see if we can get this working. Are all of you going to Hack NY this weekend? Yeah? Okay, if not, you should.
Have you ever used Johnny 5?
Yeah.
I haven't. Actually, I did use it for one project, but I haven't gotten too deep into it. It's pretty crazy.
It's like a Hello
Kind of
World.
awesome.
Yeah. Seems like that's the way to go.
Yeah,
for, like,
I
some
mean,
more complicated things.
it is. It's only a specific type of like application, though, if I remember. Like,
There's no Twilio.
it doesn't have to be used with Fermata.
Oh yeah.
You know,
Yeah.
I don't want it.
So it means that you need to like have it constantly connected to a computer, right? Okay, let's see if we can get this connected.
Yes.
Use it a lot.
That's the 10th, that's at 5 p.m.
Yep.
Let me know if you guys
double
can-
check.
Okay, I might be actually able to make that.
It's gonna be a great event.
This Wednesday I'm booked. Sunday
It
is
work
booked.
because I can just send an SMS.
Yeah, it's
to
at
my
5
police
p.m.
over at
5 p.m. And that's here, and where exactly is that?
It's in the Paulson Auditorium in Tisch Hall, Paulson Auditorium.
Tisch Hall?
Tisch, TISCH. If you go to Hacking NYU, this is a website for it.
All right.
Hacking NYU.
The Hack NYU hackathon?
No,
Is
this
it
is like
connecting to your phone?
our demo day.
Oh,
Yeah.
okay.
Doing demos,
Is this?
student
Wait,
demos on.
it's-
I thought they were trying to
Oh, yeah,
make
cool.
a Hack NYU kind
Got
of
it.
hackathon.
Let's see if
That's
this will work.
tomorrow.
What?
Yeah, the Hack NYU hackathon is cool.
No, I mean like Hack NYU.
Sorry?
Hack NYU.
Oh, it's not a hackathon. It's just like showing off student demos.
Okay.
The Hack NYU, right?
That's the name of the
Turn on it.
That one's tomorrow. That tomorrow one. That Tech and Y is tomorrow, right?
Yeah.
What time is that again?
It starts at 2.
And finishes.
Oh, he's moving. Huh?
Okay,
2 o'clock
so
on
I got it working.
Finishes at 2?
Thank you for your data there. So basically, I'm dialed into a phone call now, and I can drive this around with the keys, right?
Oh,
So,
so they wouldn't have to send the whole thing.
No. You can just come on Sunday. That's like the demos.
right, so I'm dialing it with the phone call here, and all of these are being transmitted over like some crazy data connection that dude has, and let me just restart it here. Right, you can see all the numbers I pressed on the screen up there. And reconnect it. Good. There we go. So again, right, I'm driving this over Wi-Fi, over 3G. So it's a little laggy, but not actually too bad. So it's a little laggy, as you can see, but you know, that's how it works. So it's not autonomous, but it's a little remote control robot from your phone.
Were you getting the feedback from the sonar on your phone, or?
So I actually broke the sonar module, but basically how it works is you hit the number 5, and it'll read the value back in text. So like, if I press it now, it should probably just say like 0 inches. Yeah, 0 inches, right? Because it's not plugged in. But if I had a spare wire here, I could plug it in. Let's see. I actually might have one. Any other questions? Are any of you doing hardware hacks this weekend? What do you think you're doing? You have no idea?
I might do some of my quadricopter.
Nice. Have you done anything with Nodecopter?
Yeah, so I've been playing with that a little bit. I'm gonna do some like face detection stuff with it.
You say helicopters?
Yeah, it's a quadricopter. Are there like so you have it hooked up to your USB to
Just
power?
for power, yeah. I have a 9-volt battery. That's,
So you could cool.
Cool. Yeah, I mean, that's basically it. Yeah.
What values are you testing the servos to get this done?
So every continuous modified servo has a.
Did you have to do like a guess and check?
Yeah, so you have to do a guess and check basically. Like, there's always a mid value. It's usually around 90, but it's not usually 90. Like I think for these it's 91, and you just have to like play around with it until you find the stopping point. If you use like a normal DC motor though, like you just stop the voltage to it, right, and it just doesn't move anymore. Yeah.
All right, well, thanks a lot.
And if any of you are curious, this whole thing is written up as like a tutorial online, and there's a couple other hardware Twilio tutorials as well that have like full parts list, full instructions. They're really easy to follow. So. you go.
That's also the auditorium.
So is the good part about using a server
No, that's
versus
like a
DC, is it just because it's less wiring, or is it?
It's just what I had on hand.
Okay.